Particle slides down a smooth inclined plane of elevation theta fixed in an elevator going up with an acceleration a0 as shown in the figure. The base of the incline has length L. Find the time taken by the particle to reach the bottom. Here, the whole system is moving upward with acceleration a0. So this block, this particle will experience a pseudo force small m a0 downward, and its weight is also acting downward. So total force on small m is mg plus m a0. Now, component of this total force in this direction, which will give acceleration to the block. So, component of total force along the incline equal to mg plus ma0 sine theta. So acceleration will be equal to g plus a0 sine theta. Now here AB is hypotenuse and this is base AC. So we can say L upon AB equal to cos theta, or L upon cos theta is AB, and that is distance to be covered. So we apply the formula S equal to UT plus half AT square. S equal to L upon cos theta, this is 0, plus 1 by 2. Acceleration is G plus A0 sine theta times T square. So from here, 2 will make it 2L, and this will go in denominator. So 2L divided by cos theta sine theta times G plus A0 whole square root equal to time. That is our answer. Consider next question. All the surfaces shown in the figure are assumed to be frictionless. The block of mass small m slides on the prism, which in turn slides backward on the horizontal surface. Find the acceleration of the smaller block with respect to the prism. Here, small block moves in this direction. So due to which this bigger block gets a push and it moves in this direction. Suppose acceleration of bigger block is a0 and that of smaller block is a. Now, we will consider the motion of smaller block. When bigger block moves in this direction, then smaller block will experience a pseudo force ma0 in this direction. So we can say that this is ma0, which is acting in this direction, and the weight of smaller block mg is acting in this direction. So we have to find out what is total force along the incline. So component of ma0 along this line and the component of mg along this line will make total force. So we can find acceleration in this direction. A will be equal to m, will not write, a0 cos theta plus g sine theta. This is equation number 1. Now we consider components of force perpendicular to the incline. So in this direction, there is normal direction n, and its component means component of ma0 will be ma0 sine theta. And here, component of mg in this direction will be equal to mg cos theta. So in this direction, there is no motion. So both the forces will be equal. So we can say n plus ma0 sine theta must be equal to mg cos theta. This is equation number 2. Now, let's consider what is net force on the prism. So Net force on the prism will be component of N in this direction. So if we, this is N is acting here. If we draw parallel line, so this angle is theta, this will be 90 minus theta. So, and N is in this direction. So we can say N cos 90 minus theta will act in this direction. So N cos 90 minus theta is causing the motion in the bigger block or in the prism equal to capital M A0 or N sine theta equals MA0. From here, we can get the value of N equal to MA0 divided by sine theta. We put this value here, so it will become MA0 divided by sine theta plus MA0 sine theta equal to mg cos theta. Now we try to get A0. So A0 will be equal to, we take LCM sine theta. Then this will become capital M plus small m sine square theta is equal to mg cos theta. Now A0 equal to mg cos theta multiplied by sine theta divided by capital M plus small m sine square theta. So we have got the value of A0 from here. Now we are going to put this value of A0 here. So A equal to, in place of A0, we write this mg cos theta sine theta, and there is already one cos theta, so this will become cos square theta divided by capital M plus small m sine square theta and plus g sine theta. Now we simplify it further. So it will become, we take LCM, so LCM will be capital M plus small m sine square theta. So mg cos square theta sine theta plus this all will get multiplied. So we will get mg sine theta plus small mg sine square theta into sine theta. Here mg sine theta is common, then cos square theta plus sine square theta will be in bracket, and that will give 1. So these two terms will become 1. So that will become mg sine theta plus this will be mg sine theta divided by, in denominator we have m plus small m sine square theta. Now we can write small g sine theta outside times small m plus capital M divided by capital M plus small m sine square theta. This is small m. This is the answer that was to be found here. This is acceleration of small block in this direction. Thank you for watching.